Okay, will y'all please, for number 1, will you put it in the calculator and look at the graph? Okay, go ahead and just type it into y equals for me.
What? This is been 3 pairs back. What? 3 pairs back. No. Nothing.
You made up the test on all of this.
Was yours suspended, right? Yeah. I thought it was.
All right, so I want you to graph it, and you're only going to be able to see a little bit of the graph. Then I want you to zoom out. Okay, so I'm just typing in the equation for number 1. Okay, then when I hit graph, okay, I'm looking at, I can only see like a little bit of it. Okay, probably yours looks the same. So do we know how to zoom out?
Yeah.
So zoom right here. You're going to go down to the out option. Then you're going to have to push enter one more time for it to actually do it. So if you want to watch here, it's zoom, go down to out, and then you have to push enter one more. So bloop. And now you can see the whole graph coming. Okay. So you should be kind of looking at the picture here. If I were to ask you, this was 2 weeks ago, Bobo, Botan, or Betsy, what would you tell me based on the equation? And Botan means you don't have a horizontal asymptote. Do you remember that? Okay, but look at your graph. Remember, an asymptote is a line your graph gets close to but can't touch. Can you see that there still is a line that it's getting closer to, but it's just not horizontal? You kind of see that in the picture? So that's called an oblique asymptote. Okay, so that's the only new thing we're learning before your test, which is next week. We'll review on Monday, test on Wednesday. Okay, so let's fill in some blanks at the top here. Okay, this on your screen is what an oblique asymptote looks like. It's still a line your graph gets closer and closer to. Sometimes we're going to call it a slant asymptote. But the formal, thank you, honey. The formal vocab for that is oblique. Okay, but they're the same thing. Okay, so it's going to be a line, but instead of being flat, it's going to be a y equals mx plus b that your graph is going to get closer to at the ends of the graph. And it's only going to occur when the numerator is greater than the denominator. And I want you to add one more criteria to that. By 1 power. So it has to be a Botan, but only bigger by 1. That's the only way you can get a slant asymptote. So for number 1, we're going to go ahead and run through it. We've already kind of seen what the graph looks like. But when I asked you Bobo, Botan, or Betsy, we said it was a Botan. That means that there is not a horizontal asymptote, but there could be a slant asymptote if the top is exactly 1 bigger. So if the top is an x squared and the bottom is an x, is there going to be a slant? Yes. Yes, which we already know from the picture, but put a check there. Okay, I'll teach you how to find it in a second, but let's go back through all the other features we already know how to do. Okay, every other feature you have to factor to identify. So for the top, how can I factor that? Okay, T-chart is correct. Very good. So let's do our T-chart over here to the side. ABC. And if my A is nothing there, that means it's a 1. So 1 times 4 is 4. And then what are my factors for 4? 1, 4, 2, 2. Out of those choices, what do I need them to also add to be? 5. So I'm picking 1 and 4. Can I shortcut to my parentheses? Yes, because it's just the x squared, no number on it. So it'll be x plus 1 and x plus 4. Okay, across the bottom, all I ever had was an x minus 2. We don't need to do anything to that. We can't factor anything out. X minus 2 is pretty much done. So let's just leave it like that. And then I'll just put like a check there, because the bottom part we didn't have to fix. Okay, so now come down to the bottom of your page. Okay, and let's fill some stuff in. Is anything gonna cancel out? Okay, from your expression? So then for holes, I'm gonna put none. Okay, and then I'm gonna put nothing cancels. Because remember, holes are the terms that cancel out. Vertical asymptotes are x's left on the bottom. Do I have one? Yes, what is it? It's a -2, so my vertical asymptote is at +2. And then I want you to go ahead and draw that into your graph right now. Okay, so x equals 2 would be a vertical line right here. And remember, specifically, it's a vertical line that your graph can't cross. So I'm gonna have to kind of scroll up here for a second. Okay, but x equals 2 should be like this. All right, everybody got that line drawn in? Okay, so vertical asymptotes come from the bottom. What did the top parentheses create? Do you remember? X-intercept is correct. And I have how many of them? I'm gonna have 2 of them, right? So these are gonna be my x-intercepts. And if it's a +1 and a +4, then my actual intercepts will occur at -1, 0 and -4, 0. Okay, then we can graph those right away. So let's go ahead and do it. Put x-intercept dots at -1 and -4. So let's come up here to my picture. I'm gonna put a dot at -1 and -4. So my vertical asymptote's the line I can't touch. I have 2 x-intercepts. The last thing that got hole punched is a y-intercept. And remember, a y-intercept is whatever 0's partner is in the chart. And hopefully we remember how to find the y-intercept. You're just gonna look in your table and see what goes with 0. Now, we already have the equation typed in, so will you just check in your chart? What is 0's partner? -2. Okay, and if you want to write, that should say y-intercept, it just got hole punched. And 0, -2 would be right here. Okay. So far, so good? Okay, so the only new thing we're adding is how to find the slant asymptote. Finding slant asymptotes isn't really hard, but you have to do division. So put over here to the side to find the oblique or slant asymptote. You're gonna do whatever's on the top divided by whatever's on the bottom. So I'm gonna do x squared plus 5x plus 4 divide by x minus 2. So to find that oblique or slant asymptote, you're gonna do the top of the original equation divided by the bottom of the original equation. So let's review how to do that. What would I times x by to perfectly match an x squared? Another x. And then remember, I take that x and I multiply it by x minus 2. So x times x is an x squared. X times -2 is a minus 2x. What do I do next with the signs on that row? Remember, you switch them, you flip them, so now it's a minus plus. And what should always happen to the first two? Okay, they have to cross out. If they didn't, you pick something wrong. So these are gone, and then 5 plus 2 is how many? 7x, carry down that, plus 4. Okay, then repeat the process. What would I times x by to perfectly match a 7x? 7 up top. And then I'm gonna do 7 times x is 7x. What about 7 times negative 2? Negative 14, but then what am I gonna do with the signs? So now it's a minus plus. What happens with your 7s in the front? Okay, and then 4 plus 14 means my remainder is 18. Okay, the slant asymptote is what you got on the top. So it's x plus 7. Okay, so I want you to go up to your blank and I want you to put y equals x plus 7 is going to be your slant asymptote. Now, can I just point out real quick, did I really have to finish the division and get to the remainder to know what goes on the top? No. So in the future, I'm not going to go all the way to the remainder because all I need to know is these two pieces right here. So if it's y equals x plus 7, from now on, I'm not even going to bother to finish the division. I'm just going to do it till there and then give up. Okay, so put in your blank. Slant asymptote is y equals x plus 7. And remember, that's a regular y equals mx plus b that the ends of your graph are going to get closer to. So where should I start on the y-axis? What number? If it's x plus 7. Start at 7, and then what's my slope? If x is like this, just alone. 1 over 1. So I'll go 1 over 1, 1 over 1, 1 over 1, 1 over 1. I can also extend the line backwards if I want to go this way. But remember, the purpose of that line is that your graph is going to curve off towards it, but it can never cross it. So once I have enough dots, I'm going to draw in that dotted line. Remember, it's an asymptote. So it'll be here, 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 here. Okay, and so your graph is going to approach that line, but it cannot cross that line. And that is your last type of asymptote. So you have vertical asymptotes that go up and down. Horizontal asymptotes are straight across. You can now also have slant or oblique asymptotes. Okay, now pull back up your graph and we're just going to connect the dots so that it looks the way that it looks on your calculator. So I'm going to have one piece of the graph down here. It looks like it approaches the line, cuts through and down. And then if you notice, you have another piece of the graph that's up here, kind of doing the same thing. Okay, but those asymptotes guide where your graph is kind of like sandwiched between, if that makes sense. Questions on that? Okay. We're just going to do one more since a lot of this is review. So if you'll just turn to number 2, please. Okay, first question on number 2. Once you get there, is it a bobo, a bottom, or a bed seat? Okay, it is a bottom. That means what is my horizontal asymptote? Do I have one? Okay, it's a bottom. And remember, the n means none. But just because I don't have a horizontal asymptote, it doesn't mean I don't have a slant asymptote. Slant means not only is it a bottom, but by 1. So is the top 1 power bigger than the bottom? Okay, then put a little check here for slant. Okay, we are going to have one, but we'll find it last. Okay, for every other feature, you have to factor to find it. let's do the top first. This is gonna be factor by grouping. Okay, and I made sure not to pick any examples on your practice today that you'll have to do grouping on. So it's x cubed minus 4x squared minus 9x plus 36. Group. Okay, remember, you only do grouping when there's 4 terms. Okay, so first partners, what can I take out? Correct, x squared. What's left over when I pull the x squared? X. Second set of partners. The negative 9x plus 36, what can we take out of there? Okay, negative 9 is gonna come out. And when I take out a negative 9, now my x is alone, what happens to my plus 36? 36 divided by negative 9 is now a. Thank you, negative 4. Okay, remember your parentheses have to match, do they? Okay, that's good. So I'm gonna have x minus 4 as my first factor. And then my second factor is gonna be whatever I pulled out, which is an x squared and a minus 9. Now, quick question before we move to the bottom. Is the top of that fully factored, or is there still one more thing we can do? Okay, we still need to do square roots on that x squared minus 9. Because remember, it has to be split up like all the way. You know what I mean? So we're gonna do perfect squares here. What is the square root of x squared? X, so it'll go to an x and an x. And then what about the square root of 9? A minus 3 and a plus 3. Remember, the order doesn't matter as long as you do one with a plus, one with a minus. So there's the top. It was originally cubed, so it should make sense that it broke down to 3 different factors because I had 3 different x's. Okay, go back up to your original. What was the bottom? GCF, perfect squares, or T-chart? Okay, can you do the T-chart for me, please? So I'm gonna go up to the top and label it a T-chart. Okay, but then we'll have to come back down here in a second. So for my T-chart, 1 times 3 is 3. And then what's the only way to get 3? 1 and 3. Do they also add to a 4 in the middle? Then we know we got the right partners. Can I go straight to my factors? Because x squared is alone. So it'll be an x plus 1 and an x plus 3. All right, so we have it all the way factored. First feature that I'm looking for are the ones that cancel. What's going to cross out here? And if it's a plus 3, what feature will I have? It'll be minus 3, but which feature? Whole. So it'll be negative 3 comma something. Okay, vertical asymptotes are x's left on the bottom. Do I have one? Okay, and it's a plus 1, so I'm going to switch it to x equals negative 1. And can I graph that right now? Okay, negative 1 is a straight line through negative 1. So I'm going to go ahead and graph that right now. Go up to your graph. Negative 1 would be right here. And remember, I cannot cross that line. Vertical asymptote at negative 1. What will the leftover x's on the top create? X-intercepts, very good. So I have a minus 4 and a minus 3 left on top. So that means that my x-intercepts will be at positive 4, 0, and 3, 0. And I can also graph those right now. So put dots at 3, 0, and 4, 0. Okay, they'll be right next to each other right here on the x-axis. Okay, the only feature I have left is the y-intercept. Remember, the y-intercept is whatever zero's partner is, and we'll have to find that in the calculator. So I'm gonna come down here to my y-intercept, and I'm gonna put 0, comma something, and then we're gonna find it. How do I find both of these y values? Calculator, do you type in the original? No, you have to type in the fixed version. So what that means is that anything that crossed out does not make it into your calculator. Otherwise, you'll just get errors. So on top, I have an x minus 4 and an x minus 3. On bottom, I have an x plus 1. Okay, then once you have that, go into your table and find 0 and -3's partners. So it looks like -3's partner is -21. And then 0's partner is 12. Okay, so those aren't gonna fit perfectly on the graph, but that's okay. Let's still sketch about where they would be. So come back up to your picture here. 0, 12 would be about right here. 0, 12 would be about right here. And then remember that -3 is a hole. So when you graph that point, you want to do an open circle there. And we're going to just estimate where that is since it would be way off the graph. So -3, you have your 0, 12 right here, would be 1, 2, 3, and then we'll say down like 20 would make it down. Okay. All right, what is the only feature that we have left to find? The slant asymptote, because we know it's not flat across, we know it's going to be at an angle. How do we find the slant? We take the top and the bottom and do what? You remember? Divide is correct. Okay, so for the slant or the oblique asymptote, I'm going to do top divided by bottom. Okay, but remember, we're going to be a little bit lazy and we're not going to finish the division. We're just going to get the part of it that we need. So I'm doing x cubed minus 4x minus 9x plus 36 divided by x squared plus 4x plus 3. What would I times x by to, or I'm sorry, x squared by to perfectly match an x cubed? One more x. And then remember, I multiply that x by all three of these. So x times x squared is x cubed. X times 4x is 4x squared. X times 3 is 3x. Then what do I do to all those signs? Switch them. So those all go to minus. What happens to your first two? Okay, they always should cancel out. Will the 4s also cancel out? It's a -4, and then now it's a -4 more. So what would that be? -8x squared. And then -9 minus 3 more. How many regular x's? 12x. Carry down plus 36. What will I times x squared by to perfectly match a -8x squared? -8. Do I finish the problem? No, this is the answer right here. Y equals x minus 8. So I'm just going to put blah, blah. Okay, you can finish it if you want for fun, but you don't need it. Once you get that top part, you're finished. So y equals x minus 8 is where I'll draw in my slant asymptote. So let's write it in the box or in the blank, please, for slant asymptote. You're going to put y equals x minus 8. Am I okay to come off this?
Yes.
Okay. So y equals x minus 8. Remember, that's like a 1/1 x minus 8. So I'll go down to -8 right here. And then I'll go up 1/1, up 1/1. And I'll go down in the other way like this. Okay, so remember, my graph has to exist between those lines, but you already have a picture of it. So hit graph in your calculator. Okay, you should already be hopefully zoomed out so that you can see your two pieces. One of them is down here again, and one of them is up here. Okay, make sure though that when you draw your graph that you hit the couple of dots that you drew. So I'm going to come down through 0, 12. Then I'm going to scoop through 3 and 4, and then approach my asymptote to the side. Okay, your graph doesn't have to look perfect, but it should try to at least hit those dots. Okay, then for the bottom, I have only that hole that I have to hit. So remember, I can't touch this line, so I would do maybe like this. Okay, but those asymptotes are going to guide where your line should cut through, because it can't cross either one of those boundaries. Okay. If you go on to take calculus, I know a lot of y'all are seniors, you won't even do slant asymptotes again. Horizontal, yes. Vertical, yes. Holes, yes. But slants are not that big of a deal. They exist, you know how to find them, but that's it. Okay, can you do it? All right, so turn for me just to the last page where we're writing the equation, looking at the picture. We're just going to knock out one of those since it's on your test. We're going to do number 4. Can you identify in the picture where the hole is? For number 4. Very good. It's at 4, 7. So I'm just going to put x equals 4. Then what would my parentheses have said? X minus 4. And where would it be if it's a hole? Top, bottom, or both? So for right equation, big fraction, in order for there to be a hole, it has to cancel. So I'm going to do -4 and -4. Can you identify where the vertical asymptotes are in the picture? Okay, -2 right here and 3 right here. Where do those go? Top, bottom, or both? Okay, on the bottom, it also says it here. Okay, these go in the bottom leftovers. So I'm going to put an x plus 2 and an x minus 3. Any x-intercepts? Okay, 1 and 2. Is there one more? 1, 2, and -3. 1, 2, and -3. And remember, x-intercepts are leftovers in the top. So if it's a 1, I'm going to put an x minus 1. 2, I'll put a -2. And then -3, I'll put an x plus 3. Okay, from there, last little part of this, do you observe a horizontal asymptote or a slant asymptote? Which type? It has a slant, and what's the criteria for a slant? The top has to be what? 1 bigger, right? So look at your equation. Did we do that? How many x's across the top? How many on the bottom? 3. Then would it have a slant? Yes. So I'm just going to put here, check for a bottom, and then I'm going to put top is x4, bottom is x3. Okay, and that's really just like a check to make sure. If you have a slant asymptote, the top should be exactly 1 power bigger. Okay, we kind of feel like we can do it. All right, so go ahead and pull out your practice. We're gonna do 2 of them together. Today, you're actually having to graph them for the practice. Okay, and I'll bring around scratch paper. First question we're gonna do together is number 3. I think. Or actually, never mind. We're gonna do number 1 first and then number 3. John, need paper over here? Paper over here? Paper over here? Do you want to? Wait, you can have this. The blank page. Oh, okay. Yeah. Oh, the paper. Yes. All right, go ahead and write that equation down, and then I want you to think about if it's a bobo, a bottom, or a bed seam. Okay, this is the first question. We're gonna do 1 and 3.
I don't know that.
All right. Bobo, button, Betsy, what do you think? Bobo is correct. So that means the horizontal asymptote is what? Bobo, right? 0. So I want you on your screen to click horizontal asymptote, and it's gonna always pop up at 9. You're gonna drag it down to be at a height of 0. So you're gonna click and drag so that it's on the x-axis. Right here. Got it? Every other feature we have to factor. So take a look at the top. How could I factor the top? Okay, where could I take out what number? Okay, -5 is correct. So I'm gonna GCF, divided -5 out. And that's gonna leave me with x what? +3 or -3? -3. Okay, for the bottom, you can T-chart this right now. Why should you not? What can you do first? If there's a GCF, it doesn't matter if it's perfect squares, T-chart, whatever, you GCF first. So if all of those are gonna divide by 2, let's do it. So I'm gonna take the 2 out. And now what's left over? X squared minus 8x plus. And then I'll T-chart that because now I can do the shortcut and I don't have to do those middle steps that we could usually skip now. So set up your chart with a 15. I need numbers that multiply to 15. What can I pick? 1, 15, or 3, 5. And which of those will give me an 8 in the middle? 3 and 5. How will I make it a negative 8? Both negative. Very good. So it'll be an x minus 3 and an x minus 5. Okay, before I go on, what mistake have I made that is gonna mess me up if I don't fix it? The 2 needs to stay right here. So remember, even though we took the 2 out for the t-chart, it was still part of the equation, which means it needs to stay when you put your leftovers in the calculator. Okay, from here, what's gonna cross out? Okay, x minus 3's, what feature does that create? So I'm gonna put here whole 3 comma something. We'll find the y value later. Now question, can I graph the whole if I don't have the y value yet? No, so we'll wait on that. Okay, another feature I see is a vertical asymptote. Is there an x left on the bottom? Where is it? It's originally an x minus 5, so it's gonna occur at positive 5. So click vertical asymptote. I can graph this one right now. And then I'm gonna drag it over to 5. So right there. So you should now have a flat orange line at the x-axis. You should also have one at 5. Okay, any x-intercepts or x's left on top? Any x's left up here? So I'm gonna put none. That means I just won't click that feature. Okay, y-intercept is always 0's partner in the chart. So we're ready to find those 2 y-intercepts. When you go into your calculator, what part of the equation are you gonna not type? The cross out part. So it'll be y equals negative 5 on top over 2x minus 5 on bottom. And then remember, you're just looking for those y values. So for 0, I got a half. And then for 3, what did we get? 5/4? Okay. All right, so now let's sketch those onto our sheet or onto our practice. So can you graph 0, comma a half? Yeah. So click y-intercept. And then I want you to drag it. It's always going to pop up at 9. Drag it down to about half the box. Okay, half the box. Then I want you to click on whole. And I know that I want it to be at 3. But the question is, what do I do with this 5/4? So what I'm going to do is, in my phone, you have just like a lame calculator. Okay, let's turn 5/4 into a decimal. 5 divided by 4 is 1.25. So now I know, okay, I'm going to go to 3, and then I'm going to go up 1 and like a tiny bit more. So turn this into a decimal if you don't know, if it's not like a half or negative a half or something like that. So that was really 3, comma 1.25. Okay, once you have all the features, and actually let's review. I never used an x-intercept. Was that on purpose or did I forget? That was on purpose because we didn't have any x's on top. Then you're gonna hit plot. Okay, if your graph does not hit all of the points that you plotted, then you messed up. Another easy check would be to graph in your calculator. Oops, I'm still zoomed out, but see if it looks the same. Okay, so my graph looks crazy because it's zoomed out, so I'm going to hit zoom and go down to standard and it'll fix it. So if you go to zoom standard, it'll bring you back to a 10 by 10 and they should look the same. Okay, the only feature you can't see in the calculator is the hole, and it's because you had to fix it before you typed it in. So the hole will not show up, everything else will. Got it? Okay, we're gonna do one more together, hit submit, and then go to example 3. Anybody need help over here? Okay, there's actually.
Guys, we need to do it, we need to do it fast. It doesn't matter, it doesn't matter about.
Okay, we're going to the third example now. Here. Oh, the internet's not so good today, huh?
It's free.
Yeah. That's funny, that's funny.
We all get it, I know internet is slow. Everybody good? Okay, one more, last one we're doing together. This is number 3. Got it? All right, Bobo, button, or Betsy for number 3.
Betsy.
Betsy, and if it's a Betsy, that means we DC means divide the coefficients. So it'd be y equals 2/3. If you don't know what 2/3 is, calculator on your phone, what is 2 divided by 3? Okay, so we're gonna do 0.66. So on your screen, can I graph that right now? Yeah, right? So horizontal asymptote, drag it down to 0.6. So it should be a little bit above halfway. Okay, it doesn't have to be perfect, but it should be below where the first box is and a little bit above half. Good? Everything else you have to factor. But look at your equation. What can I factor on the top? Anything? No. 2x plus 3 doesn't have anything in common. What about 3x minus 7? Same thing. So those are both done. Okay, if you get something that won't factor, that's okay. That just means nothing's gonna cancel. Which means what feature am I not gonna have for this one? So I'm gonna put no holes. Okay, x-intercept, y-intercept, vertical asymptote. Okay, do I have any x's left on the top? Yes, and remember, if it looks like this, you have 2 choices. You can set it equal to 0, or you can remember the pattern. What would happen to the +3? Would turn to a -3, and then what would you do with the 2? Divide. So let me show you. You would do 2x plus 3 equals 0, minus the 3 across, and then divide by 2. Okay, but remember, it's the same pattern, just if there's a number in front, after you switch the sign, you have to do the divide. So it'd be -3 divided by 2. Okay, for my y-intercept, I know it's 0's partner, so I'll find that in a second. Vertical asymptote, or any x's left on the bottom, do I have one? Okay, it's a 3x minus 7, so let's do the pattern. It's a -7, what am I gonna change it to? +7, and then where's the 3 end up? Divided. So it'd be +7 divided by 3. Okay, and if we don't know what 7 divided by 3 is, divide it in your calculator or on your phone or whatever. Okay, 7 divided by 3 is the same as 2.3. So click vertical asymptote. And then drag the asymptote to be a little bit after 2. Okay, vertical asymptote, a little after 2. Can I graph the x-intercept? What's 3 divided by 2 the same as? If you don't know, put it in your phone. Okay, -3 divided by 2 is -1.5, comma 0. So then in my thing, I'm going to click x-intercept. And I'm going to drag it over to -1.5 boxes. Okay, the only thing left that I'll have to use my calculator for is the y-intercept. Remember, y-intercept is the 0 partner. So I'll go into y equals here. I'll put my equation in. So 2x plus 3 over 3x minus 7. And then I'll find 0's partner. 0's partner is -3 over 7. Write it down. And then this is going to be kind of hard for me to graph. So what is 3 divided by 7? Okay, -0.4. So then when I place my y-intercept, I want to be negative about 1/2 of a box. Okay. So y-intercept, negative about 1/2 of a box. I never used the whole feature, but that was on purpose because nothing crossed out. So once you have all of those 4 features graphed, you can hit plot. You can also hit plot on here. And they should look the same. If they don't look the same, you know you messed something up. Does your practice ask you to plot slant asymptotes? No. The only things you have to plot are vertical and horizontal. So if you get a slant, you'll see it in the picture, but you're not going to have to put it there. It'll be there on its own. Okay? You have the rest of class to finish. Ask me if you need help or if you need resets. Yes, pass it right back. Yes. Hit plot. It said it knew that was wrong. Oh, your y-intercept should be on the negative top. So click y-intercept. And then click it again. Drag it down to -1/2. And then hold on, let's see if there's anything else. Your x-intercept should be at -1. And then no whole, now you should. Or now. Yes, but the window closed, so I'm gonna have to ask her to open it. You know when maybe let's do your test, get that out of the way, and then maybe on Friday. Sound good? No headache today? Even when it's this new, it's gonna be sooner. No, after.
Betsy.
Well, I hope it is good.
Thank you.
Yes. Correct. Yeah. So you'll click vertical asymptote at -1, horizontal at -0.6. Yeah. Okay. And then x-intercept should be at -5. Have you plotted that one yet? Okay. And if you want to zoom back in, remember to zoom 6.